Hey guys, I'm going to do number 10 from tonight's homework. Alright. So the equation says y equals 2 times the absolute value of x plus 1. So the parent function of this function is going to be your absolute value of x function. So we know that it's going to look like some sort of V shape. It could be upside down. It could be shifted off to the right and up, but this is what it's going to look like. So we'll make a table. And in that table, remember we want to pick numbers that are going to be easy. So first, let's pick 0 and see what happens at 0. So if we pick 0, that's 2 times the absolute value of 0 minus 1. The absolute value of 0 is 0. 2 times 0 is 0. 0 minus 1 is negative 1. All right, so 0, negative 1 is one of my points. All right, next up. The next easiest number, I would probably choose 1. All right, so that's going to end up being 2 times the absolute value of 1 minus 1. That's the same as 2 times 1 minus 1. 2 minus 1 is 1. So the point 1, 1. Okay, we're going to keep plotting as many of these as we can. So I'm going to plot easy points for me to plot, like 2. If I plot 2, I should get a 3. If I plot 3, I should get a 5, right? So I should have these points, 2, 3, 3, 5. All right, and there are some other points in that direction. I'll have the point 4, 7, 5, 9. And you can double check these if you don't believe me. But we also should try some negative numbers. And I'm just out of space over there, so I'm going to draw my negative numbers over here. I'm going to try negative 1. All right. The absolute value of negative 1 is what we're checking right now. So absolute value of negative 1 times 2 minus 1. The absolute value of negative 1 is 1. 2 times 1 is 2. Minus 1 is 1. So that's going to be the point negative 1, 1. If I plug in a negative 2, I will get 3. Because the absolute value of negative 2 is 2. 2 times 2 is 4. 4 minus 1 is 3. So I'm going to start to get the negative x values are going to start to yield positive outputs. And it should continue upward because absolute value functions are symmetrical just like parabolas are. All right, now at the end I can connect these and should connect these because I have an equation, not just points. So my function is going to look like this. All right, and it will continue on forever and ever. Keep in mind that it does have a minimum point. It is not concave up because we've got straight lines here. All right, and it has 2 roots that I can't determine right now from just looking at it, but we would be able to find those if we needed to. All right, good luck guys, have a good night, and I'll see you tomorrow.